Welcome to CIT 111, Introduction to Programming Java. My name's Eric Darso. I'm a full-time faculty member at CCAC's North Campus in the Computer Information Technology Department. I love Java. Java is a programming language. It can be used for doing all sorts of things on a computer, and it was my first language and my first love. And I hope that over the next 14 weeks you can come to explore and perhaps even to find a lot of excitement and joy in programming Java. Before we get any further, some of you may have never programmed a computer before, and you've signed up for this course as an introduction to doing so. You know it's about Java, but what is it? What can it do? I'm going to switch over to my screen now and show you a couple of examples of some simple but important programs that have been programmed in Java, so you can see where this goes. I'm going to pull up a program that you'll be installing on your computer right now called NetBeans. What you're seeing on the screen now is Java code on the right-hand side. The left-hand side, you're seeing the project navigator that includes a bunch of different Java source code files. Now let's take a very practical example. Java is a programming language that allows us to solve problems. Computers by themselves with an operating system don't do very much. The operating system works with the hardware to support what an application wants to do. So if we need to solve a problem, say randomly connecting partners for a partner activity, we might want to solve that problem using an application. Those applications can be programmed in a variety of languages. Java is an extremely popular and very robust, meaning it's sturdy. It's a sturdy language to solve a whole variety of problems. So what we're seeing on the screen now is the source code for an application called Partner Picker. Now I'm going to ask NetBeans to please compile this source code into what we call bytecode, which we can then run on the computer and interact with this program. So I just gave the command to run the program, and you'll see that it's asking me a question. How many folks are in the class? So I can say 30 people are in this class. I want to make groups of 2. Now what's important is that a functional tool actually works in the context that you want it to. So I wrote this program in order to pair up folks that are in an in-person section. Now the next thing that this program is asking us to do is enter the ID numbers of absent students. So if I just say 30 students and it randomly chooses numbers between 1 to 30 and pairs them up, if a student is gone, one or more people will not have a partner. So I've used Java to take in ID numbers, in this case it's a number between 1 and 30, and exclude them from the partner picking process. So if student number 4 and 8 are gone, I enter them. I can signal to the program that I'm done entering numbers when I enter a -1, and you'll see that it prompts me that it's done building the list, and it uses a random number generator to group students by their ID numbers. Now this is a handy thing to have done, and it's even handier because it only took about 15 minutes to write with some experience programming Java. This is a very basic example. Let me give you another example of a project that was actually made by a student in my fall semester's Java class. And so in this case, the student packaged up the application that he wanted to share, and I'll be able to run that here in NetBeans. He calls it the music scale generator, and he designed it because he's interested in how Java can help us create music. So what we're seeing on the screen is a window that was created by his Java application. He created each one of these keys and programmed the code that allows you to choose a musical key and then a type of scale. Look at all these different types of scale. I didn't even know, look at this scale, Mixolydian, the Mixolydian F scale. And I can say generate, and you'll see if it's actually showing me which notes are in the sequence to make this particular scale. Now you'll notice that if I change the name of the scale, so just a harmonic minor scale, it will once again show me the sequence of notes that make up that scale. He has audio programmed in there that I couldn't get to work on my computer, but if you download the file under Student Projects, you can run it on your Windows and Mac computers, and you'll be able to hear the sound. This is a great example of an intermediate level Java project. These are the kinds of tools that we'll be learning to make in this course. The rest of this video is going to give you an overview of how we're going to do that. How will the next 14 weeks unfold? So, there may be some of you that have not programmed Java before and don't consider yourselves computer programming interested people, meaning you're not trying to pursue a degree in computer programming. So you might be wondering why, if you're, say, pursuing the information technology support program, why would learning Java be useful for me? The most fundamental answer is that computers run programs, and no matter what particular activity you are doing with computers, whether it be supporting applications, supporting and working with teams that are using sophisticated programs, helping people use a variety of applications on a computer, no matter what your role is, by learning more about Java, we're learning more about how the computer tool works. It's a way to learn to think like a computer thinks. And in that respect, you can take that learning to help solve all sorts of other types of problems. Now, if you're interested in programming as a career, or at least professional interest to pursue, Java is an excellent language to do so because it's been around for a very long time, and the reason it stood up for the test of time is because it has three important characteristics that I'm going to now explain. The first is that Java is a portable language. Java came out of the 1990s, in fact the early 1990s. At that time, computers were developing along three key branches that were largely unrelated. So the personal computer market, running mostly the Windows operating system. The Windows operating system was running on most home PCs that people were using, as well as for small businesses. Windows was developing separately than Apple computers and their Macintosh line. These two were very separate. So a program that used to run on Microsoft Windows would not run on Apple. It was the rare program that was actually re-engineered to run on both systems. Apart from both of these was Unix. All of these still exist. Back then, Unix was large and used by corporations and businesses that had to manage large amounts of data and coordinate lots of users' efforts. And because of that, Unix developed its own path of applications. Its operating system was unique in terms of its underlying structure. So this was a problem because it meant that application designers had to choose one of these three areas to tailor their program to run on. It took quite a bit of work to take a Windows program and make it run on either Apple or Unix. In fact, for many Windows programs, they'd have to be completely rewritten in order to run on Unix. Today, Unix is very similar to an operating system called Linux, which is a free and open source system that is responsible for running most web servers. All of Google search, all of Amazon, and so forth run Linux. The insight to Java was that we need a programming language that is capable of running on all of the major distributions of operating systems without having to be redesigned. That's what we mean by portable. Where do you carry it? We can carry it across, we say, platforms. This is tremendously useful for folks that want to publish their programs and allow it to be useful for people running a variety of different operating systems. So by learning Java, You are learning a language that allows you to program for folks no matter what operating system they're running. The next element of Java that's particularly useful and a good reason to learn it is that it is multi-purpose. So let me just wipe this off here. So not only can we take Java programs to nearly any other operating system, we can also use Java to do a variety of things. So we call this multi-purpose or general purpose language. So when we say different kinds of purposes, what do we mean? For example, we can use Java to program applications that run the World Wide Web. So that means that when you are requesting a website, you are talking to a web server. Those servers can be programmed in Java. I'll show you an example of that on my screen. So I do some professional work developing database-related applications for municipal governments. This is our homepage for all of our courses at Technology Rediscovery and CCAC. And if you jump down to Database Dreams, you'll actually be able to see a link to a code enforcement, or municipal code enforcement management system that I designed for municipal governments. And I'll just show you that this particular system allows you to interact with a database that stores lots of information about properties, who owns them, if there are any code enforcement issues such as dangerous wiring or unlivable conditions in rental properties. So you'll see on the screen that I can actually use a search function to search for properties based on their address. The retrieval of this data and presenting it to the web browser is done in Java. That means that Java is a powerful tool for connecting databases to clients that are running web browsers. So Java can work on the web. Java was originally designed to be a hardware programming language, particularly for small machines. We say that they have embedded systems in them, such as washing machines or industrial control systems. Java is handy for doing that. Another thing that Java can do is data manipulation. Tons of data is stored in databases, but databases themselves are only storage containers. You need a programming language to take that data out of the database, do something with it, and present it to the user in a format that makes sense. Java allows you to do that because it has a number of code bases that allow a Java program to talk to a database program. This is what I mean by multi-purpose. This is important because no matter what area of computer programming you're interested in going in, there's a decent chance that Java will be able to be an important tool for your use in that field. Now, of course, no programming language is going to be good at everything. One of the things that Java may be less apt to use for might be something like mathematical programming that physicists and scientists use. They may use a different programming language, such as MATLAB, you may have heard of. Statisticians often program in R, which is a statistical software package. These are all better alternatives than Java for certain types of computer applications. So while it is called multi-purpose, that is a general term for the fact that it was designed to not just work for one particular type of program or to solve one particular type of problem. That's why I think you should learn Java. Let's explore a little bit more about how this online course will get you from where you are, which perhaps is having no Java learning, to being able to command the basic components of the Java language, to be able to make programs that interest you. Now, because this is an online course, we need to have a little conversation about my expectations for you as an online student and what you can expect from me as your teacher. The first thing that you want to probably know is, how do I know what to do in this course? because this is an online course, the instructions for what to do are located on the World Wide Web. I don't use Blackboard. Blackboard is a common tool used by teachers teaching online courses. It turns out to be a huge pain to use as a teacher, and I've seen that students often have login issues if their password gets reset because of the automatic password change system at CCAC. Suddenly they aren't allowed to view any of the course content. They can't upload files for assignments. The assignments disappear at certain times and you have to email a faculty member, and that person has to go into Blackboard and reset something and tell you that it was reset just so you can upload a file. This might work for some teachers, especially teachers that don't have programming experience. In my case, I have written my own website in HTML, CSS, and JavaScript that allows you to access the course content anytime you want from anywhere in the world without a login. And I'm going to explain how that's structured so that you're familiar with where to go to figure out what to do in this course. The homepage for the site is technologyrediscovery.net. You'll see a digital cow inside of a computer staring at you, waiting for you to choose the section that you'd like to jump to. Because Java is one of the most frequently taken courses that I offer, Java gets the first particular chunk of information on this website. I gave you a special purple box that contains a link to our weekly session guide. You'll also notice that CIT 111 contains links for various important course documents, such as the syllabus. This online weekly learning guide is the same link as in the purple box, because there will come a day that I'll take the purple box away, and you'll want to click on this link in order to find out what to do this week. You'll see, if we look at the weekly guide, that each week is set up with learning objectives, essential resources, weekly products of what you're supposed to turn in at the end of the week, as well as the curiosity corner, which allows you to explore some content that is not necessarily required for the course, but might be interesting for folks that like to learn more in depth. The core of the lesson is found in the lesson sequence, which is my attempt to give you a step-by-step guide for what to learn about and what exercises to work on as you go through Java. In terms of texts, you'll notice that on the syllabus, as well as number 2 in our lesson sequence, I'm encouraging you to buy a copy of a book published by Oracle Press called Java, A Beginner's Guide by Herbert Schilt. There is a more recent edition of this book. I believe there is an 8th edition. There certainly is a 7th. And this is currently being sold at the bookstores at the community college, as well as by online vendors, for approximately $20. This is a very valuable investment to make in Java learning. I think for many folks that haven't learned a computer language, the importance of having a solid reference text may not be understood at this point. Trust me that this book will be useful. I will be providing references for which chapters are applicable to the work that we do each week, and I encourage you to read those chapters first and study the exercises inside of them, because I will have designed the course content assuming that you've read those chapters. And of course, I'll tell you in the lesson sequence which sections are relevant. If you happen to get a different edition of this book, if you get the more modern edition, it costs a little bit more, and you'll have to correspond the topics that I list in the lesson sequence with the new table of contents. I think you'll be up for the task. So every week, on Monday morning, there will be content posted for that particular week. You'll see that week 2 follows week 1, and I haven't posted the content for that week yet. That will happen on Monday, February 5th. At the end of the lesson sequence each week, I will provide you with instructions for what to submit and how to submit it. Most of the submission process will involve a shared directory in which you will create a file or a set of files, and you'll upload them to that shared directory using your special ID number. Your special ID number will be created from your student ID number. We don't want to post student ID numbers on the World Wide Web because that's confidential information. But because I have your ID number and you know your ID number, we can actually use that information to create a secret ID number that is neither the school's ID number that they gave you, and no one else knows what it is because it's taken from your ID number. So the way that you'll submit is, if your ID number is this long 8-digit number, say 6512394, I'm going to ask you to choose the first 2 digits, select the first 2 digits, and the last 2 digits. Combine them to 6594. So this will be your special ID number just for my class for attaching to your files so that you can submit them. I can check them, I can see that you did the work, and you don't have to put work with your name on it and blast it all over the web. The trade-off here is that it's a little bit more work to make sure that you track your ID number, but it's tremendously less work, I think, than having to log into a system every time you want to view course content or upload a file. So that's the general process. Again, your lesson sequence is your guide. The next thing we probably want to talk about is how will you be evaluated for this course. I'll let you know that this is my first time teaching an online class. I'm teaching this class as well as CIT 100. And I'm going to use the grading policy that I employ with my in-person classes for this class as well. It's a little bit non-traditional, so I'd like you to do some thinking about it and anticipate how it will work and impact how you study for this course. You'll notice that today's lesson sequence number 1 contains a link to this page called the Self-Grading Guide. What you see on the top of this page is a photograph of me teaching high school in East Central Arkansas, which was my first teaching position. I'm sitting next to a pile of tests, graded tests. In fact, if you put these piles end to end, they would form a line that's about 18 feet long. Imagine the thousands and thousands and thousands of pages of graded, scored, entered, tracked, passed back, corrected. All of that paperwork was processed by me over the course of 2 years. I did not find that these high-stakes tests, with the amount of time that I was putting into grading them, was contributing substantially to student learning. I really believe in getting feedback to students. I didn't feel, however, that simply giving students a number and then right and wrong on questions was helping them learn particularly much. It wasn't helping them learn more, I believe, than if they had an interesting reason to learn something and a project to work on. So my approach now is, instead of grading a whole bunch of assignments and coming up with some sort of spreadsheet with points and percentages, I trust you and me to come to a general conclusion about your performance in the course. Because at the end of the day, the community college's grading guidelines say that grading is at the discretion of the instructor, and the only thing that I need to submit to the college is a letter grade, a single letter, A, B, C, D, or F. It's my opinion, and it's been my experience, that students have a general sense of fairness when it comes to grading, and that if you're asked to recommend a grade that reflects your work, most students, in fact, last semester, out of the 80 students that suggested grades, only 1 student suggested a grade that I believe was unfairly high. That student did not do a final project at all, and I did not think that a B was appropriate. Other than that, what you'll find on this page is some note cards that students filled out to recommend a grade for their course, and a reason or a rationale for why they think that the grade they suggested was a fair one. And I think as you read through these, you'll see that students like yourself, are actually very reasonable and thoughtful about what grades are fair given the amount of work that they turn in. So 2 times throughout the semester, I will ask you to fill out a note card and present a grade that you believe is fair, and then justify why it's fair. I'll review these cards. If we have an agreement, if I believe and you believe that this is a fair grade, then that's the grade that I'll enter in the grade book. If there is a difference or a discrepancy between us, we can have a conversation. We can probably talk on the phone for a minute or two. I can give my perspective, you can give yours, and in my experience, that turns out pretty well in the end. If this grading policy is uncomfortable for you, if you would like to have something more concrete, we can certainly make a spreadsheet just between the two of us, and we can grade appropriately for the assignments, and it will be more potentially objective seeming, and I'm happy to work with students on doing that. I certainly love spreadsheets, and I can make a really nice one if you want a grading spreadsheet. So that's evaluation. Let's think about how you can be successful in this course. I gave you some ideas about how you can be successful in the course syllabus, which is linked in lesson step number 1. You'll notice that this syllabus contains our high-level learning goals, as well as some note cards that have some depictions with little images about what I believe are successful elements to pursuing a Java course.